Hi everybody. So in this video I'm going to show you how to find the shortest distance between a point on a plane and two planes. And we're going to use this formula here, which is provided in the Further Mathematics exam booklet. Rather than showing you where it comes from, I'm just going to show you how to use it. So in our first question, we're told that the plane pi has this equation in the scalar product form. We've been asked to find the shortest distance between the plane and the origin. So when we use this formula, we need alpha, beta, and gamma. And these are the coordinates of a point, where alpha is our x coordinate, beta is our y, and gamma is our z. And we know the origin has coordinates 0, 0, 0. So this means that alpha, beta, and gamma will all be 0. And if we go back to the formula, we have this n1, n2, and n3. And these come from the equation of a plane in its Cartesian form. So we need to write this plane in its Cartesian form. So if we send R as coordinates x, y, and z, and we dot this with a normal vector to the plane, we'll get 3x minus 2y minus 6z will equal the constant 14. And then to put it in this form, we just need to move this 14 to the left-hand side. So now we know the n1 will equal 3, n2 will equal negative 2, and n3 will equal negative 6. And this d value will equal negative 14. And then all we need to do is to substitute these values into our equation here. So we're going to take the absolute value of a magnitude of n1 multiplied by alpha plus n2 multiplied by beta plus n3 multiplied by gamma plus the d, which is negative 14. And then we'll close this bracket. And this is all divided by n1 squared, which is 9, 3 squared is 9, the negative 2 squared, and the negative 6 squared, all square rooted. And then when we work this out on our calculators, we get the magnitude of negative 14, so just 14, divided by the square root of 49, and 14 divided by 7 gives us 2. So we know that the shortest distance between this plane and the origin will be 2 units exactly. Okay? Part B, find the perpendicular distance from this point to pi. So if we have a point 2, 5, and negative 1, now we know that alpha will be the 2, beta will be the 5, and the gamma will be the negative 1. And we're keeping the same plane, so we'll use the same values of n, and this d will be negative 14. So I'll substitute them into this equation. We'll have a magnitude of n1 times alpha plus n2 times beta plus n3 lots of gamma minus that 14, and we'll close that magnitude bracket, all divided by the same denominator of 7. We can work out our numerator, and then we get 12 divided by 7 units. And this will be the shortest distance from this point to the plane. Okay? Let's try another example. Okay, so in this example, we've been asked to find the shortest distance between the parallel planes given here, both in scalar product form. So the first thing I'm going to do is I'm going to write both planes in their Cartesian equation form. When we dot x, y, and z with normal vector, we'll get the Cartesian equation 5x plus 4y minus 2z equals 30. And when I dot x, y, and z with this normal vector, we'll get the same, but this will be equal to 50. And just to make this clear, I'll look at this one in green and this one in blue. So now we've got the Cartesian equation of both planes, I'm going to sketch the diagram. So I've sketched them both parallel to the x-axis. This might not be how they look in real life, but it's an adequate sketch for the purposes of this question. And because this constant is 30, and that the two lines are parallel, I'm saying that this plane will be closer to the origin than this plane, which is the constant of 50. So now we can find the perpendicular distance from the origin to the plane, which will be this distance here. And I can mark this over here. And then we can work out the perpendicular distance from the origin to this plane, which will give us this length. So the shortest distance between the two parallel planes will be the green length take away the blue length, which is this. So the first thing we need to do is to work out the perpendicular distance from the origin to this blue plane. So we know alpha, beta, gamma will all be 0. And then from our Cartesian equation, n1 will be 5, n2 will be 4, and n3 will be minus 2. Now our d value will be negative 30 when I move that to the left-hand side. So then we can substitute these into our equation, and then working all of this out, we get 2 root 5. So that'll be this distance here, 2 root 5. And we can go through the same process now to work out this green distance. We know now alpha, beta, gamma will be at the origin, and n1, n2, and n3 will be the same as what we have here, because the two planes are parallel. So the only difference will be when we move this 50 to the left-hand side, this will be negative 50. So our numerator will cancel to make negative 50. When we take that absolute value, we'll get positive 50. And this will give us 10 root 5 over 3. So we'll mark that on our diagram for the green length here. So then to work out the red length, we'll have 10 root 5 over 3 minus the blue length, 2 root 5. And this will give us 4 root 5 over 3. Then this will be the shortest distance between the two planes. Okay? Okay, so finally, again we've been given two parallel planes, but now you'll notice that their constant value has one positive and one negative. So again, we'll need to state the Cartesian equation of both planes. And the way we can visualize these constants is that the 20 will be above the x-axis and that the negative 10 will be below it. So if we sketch these two planes, the green one will be 4x minus 3y plus 5z equals 20. And the blue one will have a constant of negative 10. So again, we'll find the perpendicular distance to the origin, which will give us our blue distance here. We'll do the same for the green plane, which will give us this distance. And then for the distance between the two planes, we'll add them together to give us this distance in red. So for the green plane, we've got alpha, beta, and gamma. We've got n1, n2, and n3. And we know the d value will be negative 20. So we'll substitute them into the equation. This negative 20 becomes positive, and we get 2 root 2, which I'll mark on the diagram here. We'll go through the same process for our blue plane. We'll substitute these into our equation with the d equals positive 10. We can work all of this out, and we get the shortest distance is root 2. So I'll mark that on the diagram here. So now you can see the total distance between the two planes will be the 2 root 2 plus the root 2. So this will be 3 root 2. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.